a brief update on the new group structure, the new way in which Gas Goes Green interacts with its stakeholders. Then we have James Earl, also from ENA, briefly introducing himself, a new face to some of you. Then Ed Gill will give an update on the policy landscape. We have quite some time for James Whitmore talking about the hydrogen blending work overview, after which James Earl will give an update of the current plans Gas Goes Green has for 2023. And then we end up at 11:30 with James wrapping up the meeting and closing it off. With that, let's go to the next slide, which basically is Emily Jones. Emily is the head of stakeholder engagement in ENA and will talk you through the new group structure. How is your interaction from Gas Goes Green to the stakeholders? How is that set up? Emily, please.
Thank you very much indeed. So Gas Goes Green has been working closely with stakeholders over the past 2 years or so through a range of forums and channels. These include the quarterly advisory group, workshops, webinars, and the entry customer forum. Whilst this has worked well, we're always keen to improve ways of working together as an industry. So we reviewed our approaches a bit earlier this year with the aim of enabling greater participation and collaboration at appropriate points in the programme's calendar. So really making sure that we're tying up with our outputs. Also, with our new director of gas starting quite recently and the programme's outputs increasing, we felt it was a really opportune time for this reflection too. So, as you'll hopefully be aware by now and notified, which is why you're on this call, following this review, our advisory group has been replaced by an Insights Forum. And we'll also have a smaller closed group of industry experts on a new review group. These will both feed into our programme steering group, as you can see, and will be a crucial vehicle for us to be getting feedback and providing updates. Next slide. Thank you. So I appreciate this is more of a kickoff call for both the review group and the Insights Forum members. So we've got a real mix of attendees on the call today, but I just wanted to share an overview of the terms of reference for the Insights Forum in particular. So the priority for us is really to continue and most importantly, establish open channels of communication between the programme and stakeholders. Some of you will be familiar with the programme, others will be new to it, some will be somewhere in the middle. So this is really the purpose of the Insights Forum, to provide an open conduit to anyone in the industry who wants to constructively engage with us and keep up to date with what we're doing. So we'll be holding online meetings twice a year, and the objectives, as you'll see on the slides, are to be providing a transparent overview of our work activities, disseminating project deliverables, and to offer an opportunity for stakeholders to ask questions to both the team and the deliverable leads, as you'll see kind of from the setup today as well. We've published our review group member list, and I've also included a link to both the review group and Insights Forum terms of reference, and I'll pop these in the chat as well. So do feel free to have a look over those if you're not clear on the purpose of the groups and the objectives. And do feel free to let us know if you have any questions. I'll pop my email in the chat. So thank you very much for your time, and I'll hand back over.
Thanks. And again, if you have questions, do feel free to put these in the chat. Thanks for this overview, Emily. This helps to understand the type of meeting we are in and how that fits in the bigger scheme of things. Next we are going to do is have a brief introduction of James Earl, who is the new director of gas at ENA, started end of August. James will come back later in this meeting more extensively on the future plans for Gas Goes Green. So if you have any questions for him, maybe here, hold your horses and remember them for later in the meeting when there's plenty of opportunity to ask questions to James. But maybe first, James, for those of you not knowing you, who are you?
Fantastic, thanks. Hello, everyone. So it's great to see lots of people on the call today. I think I know quite a wide number of you anyway, or some I've met since I've been in the role. But I'll spend a very, very short amount of time just saying hello and introducing myself. But I wanted to spend a couple more minutes just setting the scene for today as well. So my name is James Earl, Director of Gas here at ENA. I've been in the role for just over 3 months now, and I lead our gas work at the Trade Association, which really means leading our Gas Goes Green programme, which is obviously why we're here today. And that's all about delivering the changes required to move to a zero carbon gas grid using both biomethane and hydrogen particularly. Also leading the various pieces of work we are doing with our members and wider stakeholders to feed evidence into key policy decisions. So that's key pieces of evidence around safety, particularly network impacts and system changes as well. I've also got joint responsibility for ENA's whole systems work. So working with my counterpart on the electricity side of what we do, I have responsibility for the work that we do on that, and I'll touch on that a little bit more later on today. But as I said, rather than spending too much time on myself, I actually wanted to spend a bit of time just setting the scene. So our Gas Goes Green programme has been going for around 2.5 years now, and a lot has happened in that time in this space. It's probably safe to say that hydrogen particularly has gone from being seen as a somewhat marginal fuel of the distant future to actually being a really integral part of the way we're looking to develop our energy system right now. I was in a meeting yesterday and someone I was with told an anecdote about a conference they were in back in February 2020. So if you can cast your minds all the way back to pre-COVID, if you can remember a time before COVID, at that conference, they heard a senior political stakeholder speak for 20 minutes about industrial decarbonisation without once mentioning the word hydrogen. So I think that really shows just how far we've come in the space of a really short period of time, and our Gas Goes Green programme has been a really key part of that. We as gas networks have done a lot in that time as well. We now have hydrogen homes where you can go and see how hydrogen works in reality, and you can go and cook an egg on a hydrogen flame if you're that way inclined as well. We're working on a hydrogen neighbourhood up in Fife in Scotland. We're working on hydrogen villages, Whitby in the northwest and Redcar in the northeast. And we've also continued in this time to connect more and more biomethane plants to the existing gas network, and hope this trend continues with the new, or relatively new still, green gas support scheme supporting that the sector. And of course, government's done a lot in that time frame as well. We had the hydrogen strategy in the summer of last year. We've had hydrogen production business models being developed off the back of that as well. We've had a commitment from government to 4 CCS clusters by 2030, with the first 2 of those announced as Track 1 clusters being developed currently. And importantly, we had a really exciting doubling of the hydrogen production target to 10 gigawatts by 2030 in the British Energy Security Strategy earlier this year. So huge amounts of progress over the last 2.5 years particularly. But I think it's reasonable to say that this momentum has slowed considerably in recent months for several reasons, really. One, we've had a number of changes in government that we'll all be very aware of that have made it a somewhat turbulent time in the economy more widely. Secondly, the rise in natural gas prices, of course, through the war in Ukraine, has led to increasing focus really on the resilience of the gas network in the here and now, and also pressures on cost of living that we're all too familiar with, which simply mean we are all a little bit more focused on what's happening now rather than looking too much to the future. So I think really the way I would summarize is saying we are at a bit of an inflection point, really, with everything that we're doing on decarbonisation of the gas networks and hydrogen in particular. But it's really, really important that we continue to drive forward the hydrogen economy with the same gusto that we've been doing so over the last few years, and really realise on its potential. The the world is really waking up to this. The Inflation Reduction Act in the US has been a complete game changer. It's led to billions of dollars of investment going into the hydrogen economy there almost overnight. So our Gas Goes Green program will be doing everything we can to support the continuation of the hydrogen story in the UK next year and beyond that as well, including particularly by supporting government to make key decisions to move the hydrogen economy forward by providing the right evidence that they need for those. So hopefully that sets the scene and should hopefully lead us nicely on to the next speaker, Ed, who will be speaking a bit more about policy.
Thank you so much, James. It's good to have you on board. Thank you for that overview of the progress since the last couple of years, and we look forward to inviting you back in this meeting to discuss the plans for the future of Gas Goes Green. If you should have any questions for James Earl, as Michiel said, hold your horses. There will be plenty of opportunity to do so in the final half hour of this meeting. That being said, I would like to introduce and welcome Ed Gill, who is Head of Markets Policy, has been since September of this year. Some of you may be familiar with him as he used to do the communications for Gas Goes Green. The government is aiming for several key policy decisions in 2023 and 2026. And I'd like to invite Ed to tell us about the current state of play in the policy landscape leading up to those important decisions. Ed, over to you.
Thanks, Leonard. And good to see a number of familiar faces on the call. So if we just go to the first slide, please. I'm going to give a bit of a view of how we're viewing the policy landscape at the moment. And the purpose of that is just to demonstrate our thinking around this area at the moment, this work at the moment, and then obviously how the Gas Goes Green research is feeding into that, and then a bit of a run through and kind of where our positions and are on that. Some of it won't be a massive surprise for you, but I think it's worth just running through that, just to have a bit of a refresh. As James says, we're at a point now where we're going to be setting out what we're doing going forward, and I think it's worth just giving some consideration as to how all of that's going to link together, particularly with ENA's policy work as well. And that's something that we do want to be doing more of, which is linking the hard work that's done through the Gas Goes Green programme into our markets policy as we describe it, which is mainly our departmental policy, joining it together with our regulatory policy work as well. So there'll be no massive surprises here on the current policy landscape to most of the people on the call today. We've obviously had the proposals for hydrogen transportation and storage business models, big consultation. Know that many of you will have put a response into that last month, setting out the top line vision for transportation and storage, role of network infrastructure and associated business models, questions there about the role of hydrogen storage, and then also blending as well. And we, like many of yourselves, we also put a response into that. We have coming up the 2023 hydrogen blending decision as well next year, which is coming quite fast. We've obviously done a lot of work on Gas Goes Green in the past with Britain's hydrogen blending delivery plan, and then also the industrial clusters blending piece just earlier this month, end of last month. And then just a couple of other things working their way through Parliament at the moment in terms of the Energy Security Bill, which was somewhat delayed but is now getting going again. The Future System Operator is very much part of that, as you will be aware, and then also the enabling legislation for hydrogen village trials. We're expecting a couple of consultations as well from government that we're keeping an eye on. Principally the hydrogen ready boilers consultation, which I think is fair to say has been a long time coming. I remember some of us were calling for that almost a couple of years ago now from government on that, but we understand that's on its way. And then also consultation on hydrogen certification as well, which is going to be important from a guarantee of origin perspective, and how we use the demand side of the market to create that pull through for hydrogen. And if we go to the next slide, please. So just a quick word on how Gas Goes Green research is informing ENA policy at the moment. So in our recent response to the hydrogen transportation and storage consultation, we drew heavily upon that. and we will be increasingly going forward through other consultations as well. So the Gas Goes Green pathway obviously underpins a lot of our thinking there with that forward view out to 2050, which was developed with extensive stakeholder engagement way back in 2019 now. More recent documents though are playing an important role. The Britain's Hydrogen Network Plan, the Green Gas Scorecard, providing all those good stats about progress, particularly in relation to biomethane, iron mains risk replacement and so forth. The Systems for All Seasons research has played an important role in demonstrating the value of hydrogen storage, and particularly through curtailed wind and how that can offset the need for new generation infrastructure elsewhere in the market. And then the Hydrogen Blending Delivery Plan has really helped give us that detail when we talk about the strategic and the market approaches that we could take to meeting the hydrogen blending target, and then helping them inform our responses to government proposals in that area in a really quite detailed way. And then also the enabling hydrogen blending from industrial clusters. So there's a key role for this forum as we look to the future as well, about when we're developing Gas Goes Green research, about what your role is, how you're informing that research, and then how that's flowing through to E&A policy, markets policy as well. Next slide, please. And then just a brief summary of the kind of 4 key policy areas and positions that we're focusing on now and where we stand with those. So, and I suspect there's a lot of shared sentiment for these around the room, as it were. On transportation, the need for speed on business models, progression with that as quickly as possible, particularly given the projects, those initial projects, we wanted to reach final investment decision in the next 18 months or so. So we really need to see some progress on that as quickly as possible. It won't come as a surprise that we favour a RAB model for transportation, and we think RIIO-2 should be used as an interim measure if things can't move fast enough on that front. On the blending side, we felt that the government's most recent proposals were a little bit too focused perhaps, and that we wanted a more ambitious approach. So the government's proposals to have a reserve off-taker focused on mitigating volume and demand risk in the early stages of the hydrogen economy. We think there should be a flexible off-taker approach where basically hydrogen can be moved around as and when it is needed. And absent at the moment are business models. So no business models at the moment have been proposed for enabling hydrogen blending. We think more work needs to be done in that area. On storage, we feel there's a need for a strategic decision about the role of storage in the wider energy system at this point in time. RAB could be the best approach, but obviously there are different types of storage, different types of duration, different types of market interactions. A RAB might be suitable for some, it may not be for other types of storage. So it's something that needs to be carefully considered in line with what that strategic vision and role is for storage in the energy system. And then finally, on the governance side of things, we're seeing, obviously, as I mentioned before, the progression of the FSO finally through the Energy Security Bill. We want to ensure that there's parity with hydrogen alongside electricity on that. As James was saying in his opening remarks, hydrogen's gone from being perhaps a smaller part player in the decarbonisation debate to really being at the front of it. It's important that the FSO is equipped when it's making those future infrastructure decisions to consider hydrogen with a degree of parity to electricity, or with parity, I should say, to electricity, and they've got the skill set required to do that. Worth bearing in mind, of course, the FSO is going to be spun out of the ESO as well. Strategic policy statement is required. That was obviously promised in the British Energy British Energy Security Strategy back in March, I think it was April time. That's crucial to providing Ofgem with the guidance it needs to, and the confidence it needs to make decisions through the price control, particularly given that we have things like net zero reopeners now. There are question marks there about innovation funding for the future as well. And we want to see government give Ofgem the confidence to make those decisions and know that they've got the backing for the government to do that, which will hopefully get us where we want to be. And as I mentioned, at the moment, RIIO-NIA funding is only guaranteed until 2026 at the moment. That's a big one for us. It's the oil in the machinery, in the wider innovation machinery that makes all the cogs turn, and we really need to see some clarity on that going forward. Thank you.
Thank you very much, Ed. Next, I would like to introduce James Whitmore, who is Innovation Manager, Strategy and Future of Gas at Cadent. He also chairs the Hydrogen Blending Steering Group. Note that for this section, we will be using Slido. Slido is our polling software of choice today, We have the details here. Should you have any questions to James Whitmore on hydrogen blending, you can post those questions here by either using the QR code or going to slido.com and entering the code GGGIF, Gas Goes Green Insights Forum.
Great. Thank you for the introduction. So it's a pleasure to be here to take you through some of the work we've been doing under Gas Goes Green in the hydrogen blending space. However, what I'd first like to do is just recap on what hydrogen blending is all about, and why we see a need for hydrogen blending in the transition to net zero. So what is hydrogen blending all about? So we know we need to move from burning natural gas to 100% green alternatives. Whereas blending hydrogen into existing methane means we're still left with quite a bit of methane. So what's that all about? So currently we've got 85% of the homes connected to the UK's gas grid, and the majority of industry also burn natural gas for heat and for power, etc. And the switch to 100% green alternatives isn't going to happen overnight. It's going to take a number of years, right out until 2050. Hydrogen has already been flagged as the solution for heavy industry, and also has the potential to decarbonise heat as well. UK government recognise this. James already mentioned the plans for a hydrogen neighbourhood and a hydrogen village as we go forward this decade, but also there's plans for around 10 gigawatts of hydrogen production by 2030 as well. So where does hydrogen blending fit into all of this? Now, the USP of hydrogen blending is that hydrogen blending can be a flexible off-taker for hydrogen. And this is because no changes are required to the 20+ million homes that we've already got connected to the gas grid today. So the existing boilers and the existing appliances that we've got that are burning natural gas today, if a blend of hydrogen is introduced to the network, they'll continue to operate as they do. So what this means is that hydrogen blending has the potential to then boost production. So in the early days of the hydrogen economy, we're going to see hydrogen production directly linked to demand, and that inherently creates volume risk, because if demand drops off, hydrogen production will also need to drop off, unless there's storage in place. And we know from the recent TNS consultation, storage business models are likely to take some time to be in place. Also the physical infrastructure. So hydrogen blending actually can act as an early source of demand, boosting production, enabling production to increase to the government targets. What it also does is it enables producers to manage volume risk when demand is online. So as we know, demand isn't always going to be 24/7, 365. There'll always be downturn in demand, etc. So there's always going to be this up and down of demand. And by enabling blending, and blending being a flexible off-taker, enables the excess production to be spilled into the network or injected into the network at those times. And then the final piece around production is that it decouples production from what we know as the industrial clusters. So at the moment, we've got plans for production and demand to be linked via these dedicated hydrogen networks. However, by enabling blending, we can enable production anywhere where there's a gas network, effectively. So more geographically diverse production, such as wind farms and green hydrogen, is more likely to be able to expand because it can inject into the grid. And what this does, this supports the government targets for around 5 gigawatts of that 10 gigawatts of production to also be scaled up. So in addition to just boosting production, blending can also provide a benefit to the power grid by reducing renewable curtailment. So at the moment, wind is being curtailed every year. So when there's excess wind, wind turbines are having to be switched off. So last year, around 2.3 terawatt hours of wind was curtailed. And to put that into context, that cost around £507 million in sort of curtailment penalties. Curtailment's only expected to grow, so the the ESO have got plans and the government have got targets for a fully renewable power grid by 2035. So we're going to need significant increases in wind and solar. So that, and if you look at National Grid's recent ESO report from 2022 this year, we expect curtailment to peak in around 2035 at 50 to 80 terawatt hours per year. Now, hydrogen has been flagged as one of the solutions to resolve curtailment, because when we've got excess wind, we could produce significant amounts of hydrogen, which could be stored for long, long durations, well, indefinitely really, and used for different parts of the season when we have higher demand. But at the moment, there's nowhere for that hydrogen to go. We need to build out storage. Investment needs to go into the hydrogen economy, whereas blending can be done as early as 2023, which I'll come on to in a moment. So it enables that renewable, that curtailment to be reduced from an early phase. And whilst doing all of this, hydrogen blending can green the gas grid. So if we look at the heating building strategy from last year, the document flagged that there's a need to green the gas grid now, and that's because the scale of the existing users connected to the gas grid will take a significant number of years to transfer to green alternatives. We've got really challenging carbon budgets coming up, so the 4th, 5th, and 6th budget as we transition to net zero. So we need to start making a real impact on the emissions that are from the users that are already connected to the gas grid today. And up to 10 million tonnes of CO2 can be saved from blending alone, and that's equal to heating around 5 million homes fully with green resources. Next slide, please. Okay, so it's not just gas goes green or just as see the benefits in hydrogen blending. UK government also see those potential benefits in blending, and are expected to make a policy decision on hydrogen blending next year. And where this initially came from, the 10-point plan was released at the end of November 2020, and this committed to work with industry to undertake the necessary testing to enable 20% hydrogen in the gas grid by 2023. The key driver for this was our HyDeploy project. So this is led by Cadent, Northern Gas Networks, with a consortium of other experts. And HyDeploy so far has proven that blending can be blending of hydrogen into the gas grid can be received by all of the domestic consumers, and he's working through the industrial consumers at the moment. And the project is due to conclude in 2023. And HyDeploy is focused around the gas distribution network. We also have National Grid, who are running the High NTS Future Grid project, and this is going to follow HyDeploy in generating evidence for the transmission networks for blending in the future also. If we look at last year, the UK hydrogen strategy reinforced the commitment to make a decision on hydrogen blending. Now, BEIS at the moment are undertaking what they call a value for money assessment, and that's being undertaken at the moment, and they're expected to conclude that early next year. So this is really, so we've got the sort of industry looking at the safety elements, and then BEIS are looking at the economic case for blending, and we're hoping to see a minded to position in the new year. And this will all lead to a final policy decision, as Ed mentioned before, which we're expecting at the end of 2023. Next slide, please. So this leads me on to the Gas Goes Green programme. So what are we doing under Gas Goes Green to support this, to support policy and to support hydrogen blending? So our mission is effectively to look at what would be a practical and economic framework to enable hydrogen blending, both to support the policy decision by BEIS, but and beyond, to prepare the networks, subject to a positive policy decision. So we've got HyDeploy and Future Grid looking at the safety elements. We've got BEIS looking at the sort of economic case. But how do you practically go about implementing blending? So some of the key questions that we're looking to answer are: so what is the blending opportunity within the network? How much blending could actually take place, and how much production could we support? How will blending physically happen? So we've done 2 trials under HyDeploy to date, but we've not, to blend actually into the network will look a bit different. So what does that physical kit look like, and what are the costs associated with that? What do the regulatory and commercial frameworks need to look like for blending? And this includes things like how should access to the network be provided? So blending hydrogen is a different gas, so it just requires slightly different considerations to some of the connections that we've got today. And then what are the timescales? So what are the likely timescales that we could actually start to introduce a blend into the network? Next slide, please. Okay, so if I start with the blending opportunity. So we undertook a recent piece of work where, and this was across all of the gas networks, where we looked at, what's the capacity of blending hydrogen into the network. And this was we produced a high level document. Obviously, bear in mind there's a lot of detail that goes behind this, but actually what we've found is there's a significant capacity for blending 20% hydrogen across the NTS and the distribution networks, and this equals to around 60 terawatt hours per annum. Now, to put that in context, that's equivalent to heating around 5 million homes. So we're talking about blending, but if that hydrogen was being used to fully heat homes, it would equate to around 5 million homes, which is really, really significant and really, really a worthwhile sort of prize to go at. And that equates to 10 million tons of CO2 a year. If we just look at the distribution network alone, of that 60 terawatt hours, around 35 is within the distribution networks, and again that's equivalent to 3 million homes and 6 million tons CO2. So this document is now live. So this is public, so you'll be able to get this from the ENA's website. Maybe we can stick a link in the chat as well. But what it does, it actually looks at the different local distribution zones as well. So you can sort of see how that 60 and 35 are broken up into areas across the UK, which provides a good insight into the blending opportunity for producers and for investment in those areas. Okay, next slide, please. Okay, so that's sort of the opportunity. So then, but how would blending physically happen? So to tackle this problem, we've looked at, well, what do we need to, I suppose, what things do we need to manage to inform how you would build the plant? So we looked at developing a functional specification for blending facilities, and what this does is look at primarily the regulations. So how would we maintain compliance with the regulations, but then also looked at what technologies are out there for gas mixing, for gas quality, ownership models, etc. Now, the 2 key regulations that we need to consider are GSMR. So HyDeploy is seeking to raise the limit for hydrogen blending within GSMR to 20%. So that's an assumption that we've made for the functional specification. And then the other main regulation that we need to consider is the gas calculation of thermal energy regulations. So earlier this year, we consulted through the Future Billing Methodology project on a billing methodology for both hydrogen blends and biomethane, so for a mixture of all gases. And one of the conclusions out of that was actually in the early days, you can actually blend significant amounts of hydrogen under the existing regulations. And what this means is, though, you're probably more directed to higher flow locations, such as the local and national transmission systems, where you can get significant quantities of hydrogen away. So we use that as an assumption in the functional specification as well. And then what that enables us to do is then to go and work within those regulations to design some kit to see what that looks like. So we've also done an assessment of gas mixing as well. So hydrogen blending is quite it's different to, I suppose, biomethane blending. So because we've got 100% hydrogen effectively being blended into a natural gas stream, we need to make sure that 20% mix is is what we call homogeneous, and that we're not getting bits of 100% hydrogen or 50% hydrogen. So we've got a steady mix of a blend out the back of the facility. So we've looked at various mixing technologies, and we've undertaken some what we call CFD modelling to look at how the gas mixing takes place, and we're calculating. So what's the sort of distance of pipe work would be needed to allow that mixing to happen? So this is work in progress at the moment, but it's actually much shorter than we initially envisaged, which is good for the infrastructure because it means everything can be a bit smaller, a bit more compact, and obviously cost less. In addition to that, we look at then, so what sort of analyzers would you need to manage the gas quality to maintain compliance with the regulations? How would you maintain compliance with the billing regulations, etc. And then finally, ownership models. So this is where it gets quite interesting in terms of who would own what bit of kit. So we've got existing biomethane models out there at the moment, which give us a good sort of standpoint actually to work from, where you go from one extreme where the gas network sort of owns and operates everything, but we're also considering what does it look like for a third party delivery facility operator or the producer effectively to own some of that kit, and the networks own minimum amounts of that kit. Both have pros and cons. The latter tends towards more of probably a more commercially viable solution, and allows things to sometimes happen a bit quicker. So we're considering all of those, and we'll put all options on the table effectively. And then to test the functional specification, because this hasn't been done before effectively for hydrogen on the network, is we need to test to see if it works okay. So it's great in principle writing down all the things that we need the kit to do, but then when you actually go to apply it to a real site, as it were, does it work? Can you fit the kit on a site? Is it affordable? Is there any constraints, challenges, etc.? So what we've done is we've undertaken a number of case studies at various types of location on the network, and basically designed at high level what the site would look like. And what this enabled us to do is to then come out with a practical design, but also give us indicative costs. And this has been really sort of crucial actually, because we've been supporting BEIS with their value for money assessment, because we've been able to provide them with some costs that are actually based on an educated piece of work. So this piece of work is currently ongoing. We're expecting this to conclude actually not too long, so at the end of this year. And it's an NIA funded piece of work, so we'll make all the findings publicly available. Brilliant. Okay, so far we've gone from, so you've got can we safely blend, which is the high deploy stuff, the economic assessment. Is there capacity to blend within the networks? Yes, there's lots. And then how would you physically do it? And then you come to the question, well, what does all the regulatory and commercial frameworks look like for blending? Do we need a wholesale change? Is it a totally different approach to how we would manage natural gas today? So what we did is we followed on from the delivering Britain's hydrogen blending plan work earlier this year, and we undertook a piece of work where we looked at, if we were to enable blending sort of ASAP, how do we think it would work, and what do we think the frameworks would look like? And this was really a temperature check from the networks and from industry within the industrial clusters. So although this report is badged as from the industrial clusters, actually the findings are across the board. It's just that we got the views from industry within those clusters to help frame the report. So what were the conclusions of this? So roles and responsibilities actually largely remain. Gas is traded at the national balancing point on the basis of energy, so therefore hydrogen should be able to be traded in there as well. So we don't need a whole new framework around blends, as it were. early hydrogen blending, as I mentioned before, can commence within the current billing regulations, which saves a lot of time and a lot of cost in reforming those regulations. That said, the networks are continuing to look at the feasibility of a future billing methodology in its own right, not as a precursor for hydrogen blending, but for the enhancement that it could bring to both hydrogen and biomethane blending in the future. But it's important to note it's not a a prerequisite for blending to occur. And then some of the suggestions out of the report were we're probably going to need to review the capacity and connection methodology for enabling hydrogen blending, which I'll come on to in a second. And we'll probably need to review the transportation charging methodologies. Now, there's lots more in that report. They're just some of the sort of key headlines, but effectively the overall result is the existing gas frameworks largely work for hydrogen blending. Therefore, it should be a fairly straightforward and easy thing to implement once we've subject to us securing a positive policy decision from BEIS. Okay, so what's in store for 2023 then? So in terms of policy, I've already mentioned that BEIS are looking to conclude their value for money assessment early in the new year, and then make a final policy decision later in 2023. In terms of the safety evidence, high deploy evidence will complete. So that's for the entire distribution network. So from end to end, so from the network to end users. And Future Grid is going to continue generating evidence for the transmission system as well. And then within the Gas Goes Green programme, we've got plans to do a deeper dive regulatory and commercial review. So this is to move on from the report that I just mentioned around enabling blending from industrial clusters to do more of a page turn exercise. So this is more of about, so we don't think there's wholesale changes needed, but what things do we want to or need to tweak to make them better, or work more for blending, as it were, so we can start to shape what any sort of code modifications may look like, or just sense check that there's nothing that we've not picked up before. So then, subject to a positive policy decision, we've almost got a manual that's ready to go, so we can crack on and implement those tweaks rather than actually start again. And then this second bullet point around capacity and connection methodology is a key point, really. So this is where we understand that blending hydrogen isn't the same as blending biomethane into the existing gas grid effectively. So with biomethane, you've got methane mixing with methane, so you can put as much of it in as you want effectively. You can have multiple connections, you can sort of have connections everywhere. Whereas with hydrogen blending, it is slightly different in the way that there will be a limit, which is likely to be 20%, subject to the high deploy work. And there'll also be there'll be sort of limits around the billing as well. So what that means is that we need to just think more about how we offer connections and capacity, because if you have two or more connections in series, potentially the second connection needs natural gas to then blend its hydrogen with. So if the first connection's already got 20% in, what does that mean for the second one, or vice versa? So what we're going to do is we're going to do a lot of work in this area to determine, how best should we provide connections and capacity to enable a fair market for producers, but also enables us to manage gas quality and actually deliver the benefits that blending should deliver. So that's a big piece of work that we want to do in the new year. And then in addition to that, we'll also work up a blending timeline. So these two sort of go hand in hand. So when we look at the distribution networks and the national transmission system, if we were to receive a blend in certain parts of the network, what does that timeline look like, to help inform industry, but also to help inform government with their policy decisions as well.
All right. Thank you so much, James. for this very comprehensive overview. We've seen a lot of interaction in the Slido already, so I want to thank the participants for voicing their questions. I also want to remind you that you can upvote questions so that we can prioritize that during the Q&A. So James, we've got immediately a couple of questions for you, starting with one on the CO2 benefits from blending. Question is, does the CO2 benefits presented in the previous slides assume entirely green hydrogen production, or is it mixed?
So the CO2 benefits are projected benefits from hydrogen at end use. So it's a good point. That doesn't consider the type of production as it were. It's removing emissions from the end use.
All right, that's clear.
Yeah, that's
clear and concise. We've got a lot of questions, so I'm hoping for a lot of those answers as well, James. Thank you. Second question is, who will be purchasing the hydrogen to blend into the network? If it's more than the cost of gas, how is hydrogen going to be incentivized? And there was another question on the volume risk in blending. Maybe you can say a little bit about who will be purchasing the hydrogen and what is the volume risk?
Okay. So BEIS are currently considering that question. So who will purchase the hydrogen? At the moment, for gas, we have a shipper and a retail market effectively. So shippers buy the hydrogen from shippers buy natural gas, sell it to the retail market, and then that gets packed to consumers. So that's one model that could be implemented for hydrogen blending as well, and something that I believe BEIS are considering. There's other options out there in terms of the networks have obligations to buy natural gas at the moment for gas that's used within the network. The networks could potentially purchase some hydrogen as well. But I think those two things are sort of being worked through at the moment, but I don't see there being I don't see why there should be an issue in the sort of shipper supply model. If I'm honest, it feels like that's a model that would provide liquidity to the market and get things going. But BEIS will need to consider that because obviously there's hydrogen networks at the moment which may have a different approach. So how would that plug together? But yeah, it's a question they're working through at the moment.
Right, so it's also still a little bit of an open end on how this will materialize in the future.
Yeah.
Thank you. Next question. So on blending, can you address the tensions regarding blending, creating a relatively small dent in the gas grid CO2, but using a potentially relatively scarce hydrogen supply?
So this is where the flexibility of blending, I think, is really important. So what I suppose we're acutely aware that blending isn't the end game. We do need to move to 100% alternatives, i.e. 100% hydrogen in the future, or other solutions where that works. But what blending does is it enables production to scale, and it enables production to scale before other demand can come online or access that hydrogen. So it enables the production to scale in advance of those other intensive users, as it were, or the other users that would potentially use it. Then once they know the hydrogen is being produced, they can be a consumer for that hydrogen. And then the blended hydrogen could then potentially ramp down because of that flexibility that it can offer. So I don't see there actually being a real tension here, because I don't think what we're saying is you put the hydrogen to blending and not to the others. It's an enabler. It enables enables the others to come online as well.
So you're actually saying that there is an additional benefit to hydrogen blending, which is system flexibility.
Yeah. Absolutely. Yeah.
All right. Thank you, James. Next question. Why is the RAB, regulated asset base, the focus for storage with other options? Doesn't this dampen signals regarding REMA on sustained response and interaction with electric wholesale?
This is one for me, isn't it?
I was going to say I'd kindly pass over to Ed, I think.
So, I mean, as I said in the opening slides, there's a whole different range of options here for what role storage is going to play under the gas goes green pathway. Everything from the long duration seasonal storage using old oil and gas caverns, all the way through to co-located stuff with onshore wind and solar at a distribution level. So there's a really wide range of different options here for what role hydrogen can play. So the nature of storage types and infrastructure is important. What the appropriate owner-operator or owner-operator arrangements are that flow from that are important, and then what contractual relationships with the market result from that. I would say a RAB, we would see it probably as more likely for strategic long duration storage. And we definitely see the advantages for RAB in terms of securing investment through the certainty that can provide. Now, obviously, REMA is talking about locational pricing at transmission level as well. And that longer duration strategic storage playing a role at that kind of systemic level, if you like, is going to more likely to be far more complex than it is perhaps at the local level, far more moving parts. I think one of the concerns that we have around, or one of the points that we've raised around locational pricing under REMA, is the fact that it's only just wholesale pricing, basing things on wholesale prices. Wholesale prices is only one part of the mix here. You've got to think about planning costs, supply chain, workforce, and so on. So we have a concern about that, and therefore the ability of locational pricing to send those right long-term investment signals to the market. And as I say, that gets more complex as you move further up the chain in terms of strategic role of storage. And it's probably just worth touching briefly on, if you think about Rough, and the reason why Rough originally wasn't reopened a few years back was ultimately because the market wasn't sending the right signal to Centrica as the owner to spend the money to upgrade, to make the necessary safety upgrades to keep it running. So that's kind of broadly speaking. I think we would see RAB probably more likely for the bigger storage projects, and therefore thinking more along those lines.
Thank you, Ed, and thanks for stepping in here. Next question. This one is for James Whitmore. That's clear. What is your perspective on the government's current position on hydrogen blending leading up to the decision in 2023?
Okay, so I think I mean they are seriously considering blending. Obviously there was key intent to gain as much information as possible from the TNS consultation. I mean, they're not letting too much out of the bag at the moment, except that we're providing them with the the information, as it were, to enable them to make the economic test, to then come out with a policy decision next year. But I think the fact that there's an intent for a policy decision next year, and to work with industry to do the testing and and doing the value for money case is all positive signals that they see a potential benefit in hydrogen blending. But I suppose without speaking on on their behalf, we'll have to see what they say. But I mean, I don't know. I know some of the bays were invited to this call. I don't know if anybody's on the call and they wanted to chip in, but yeah, I'm quietly optimistic. But I think proof will be in the pudding, won't it?
Thank you, James. And as you see, I combined it with another question on whether the government is keen on blending. I think you've successfully answered that. But again, it's still waiting on talking. It's worth talking with the government and maybe not about the government in this sense. And we'll have to wait.
Yep.
More technical question, a very good question as well. How can hydrogen blending be at diverse locations? So imagine you have a downstream location which blends up to a maximum 20%. How can upstream blend anything in?
Yeah, so this is exactly the piece of work that we're looking to kick off next year to get in, really under the skin of. So when we say blending can enable diverse locations, what we mean is the gas network is very extensive. With hundreds of thousands of kilometers of gas network. There's around 17,000 kilometers of transmission network alone, which is actually probably the ideal place for blending, and that's not just in the NTS, that's within the distribution networks as well. But what it does mean is and the question's spot on, is that we can't just have blending connections here, there, and everywhere. There needs to be some thought that goes into that to enable an efficient use of the network and to really see the benefits that can be gained. But we don't want to preclude connections at the same time. So yeah, it's a good piece of work we need to run through. But I think providing the breadth of the network that we've got, we can provide the right access at the right locations to enable producers, but do the job that it's intended to as well.
Right, thank you, James. A question on biomethane. What are the current key blockers to increasing biomethane volumes within the networks as we continue a transition towards blended or 100% hydrogen?
So in terms, I mean, the framework and everything's obviously already in play for biomethane, has been for a long time, and Ed and James, I think, both mentioned the Green Gas Support Scheme as well earlier. But in terms of biomethane blockers, actually, the one of the key constraints that's been to biomethane over the years has been what we call network capacity. So this is space within the network itself. So it's not a gas quality thing, the same as what we're talking about with hydrogen. It's more around, can I squeeze any more gas into those pipes that's already there today? And one of the reasons I suppose that is when we talk about injecting into the lower part pressure tiers of the network, or some of the more some of the parts of the network with less demand, should we say. And this is another reason actually why injecting hydrogen blends into the what we call the transmission systems is more ideal, because it's not stealing that demand from prospective biomethane consumers either. But yeah, I mean, as we transition towards blended gas or 100% hydrogen, there should be no conflict really with blended hydrogen. However, 100% hydrogen will need, they're going to be different networks. We're not going to have 100% hydrogen with biomethane or with blends. When we move to 100% hydrogen, there'll be dedicated hydrogen networks. So yeah, there's no conflict there, as it were.
That's very good to know. No conflicts in hydrogen versus biomethane. It's more complementary in separate systems. And yeah. In view of time, I'd like to take one more question, and then we'll get back to James Earl. So final question on the 20% hydrogen blend. Is that compatible with existing meters? 100% hydrogen requires entirely new meters, but never heard about requirements for blending.
Great question. So we've done an extensive piece of research with our HyDeploy project, which has taken all of the different types of gas meters that you can that you get across the network, but also in consumer premises, etc. And that was with the National Engineering Laboratory. We've got a bespoke hydrogen test rig, and tested all of these meters on 20% blend and looked at the required sort of accuracy levels. There is the accuracy of the meters with a blend was, it was in the mix of the accuracy of the meters just on natural gas, and nowhere near the accuracy tolerance limits that's allowed. So for a blend, all of the meters will continue to be as accurate.
All right, thank you so much, James. And with that, also thank you for your very informative presentation and clear answers to the questions. Once again, we want to thank you, the audience, for your participation. It's very much appreciated, and we hope to have sufficiently answered at least a lot of your questions, not all. And to that end, we will archive the questions that have not been answered. And should we have a couple of minutes at the end of the meeting, we may come back to those. That being said, Michiel, back to you.
Thank you, Lennart. Thank you, James. Let's return to the other James Earl. with the last point on the agenda, which is about the current status of Gas Goes Green's plans for 2023. And this is also your opportunity for all the participants to again ask questions, any questions you like to ask James. So that can be about the program for next year and the current status of that, or any other question. And again, you can upvote or down. You can upvote any question that anybody else put in the chat. With that, let's go to James Earl for the plans for Gas Goes Green in 2023 current status.
Thank you very much. Next slide. Yep, thank you. So to kick this off, I just wanted to go back to some of the points I was making at the beginning about the hydrogen sector being at a bit of an inflection point, and where we really need a bit more certainty around support that's going to be available for hydrogen, when that's going to come, how hydrogen will be used as well. So I think with that overlay is really reflecting the way that we're approaching 2023 on the programme. The first 2.5 years already has been about building up that pathway and vision, but really we're trying to pivot the programme more towards providing the key pieces of evidence needed to support key decisions to be taken and provide some certainty to the sector around key policy areas such as blending, which we've just talked about, but in other areas as well. So hopefully in what I'm about to describe, you'll see that come out. So the first piece I wanted to touch on was a piece that we're developing at the moment, which we're calling the Hydrogen Vision. This will be a follow-up to our Pathway to Net Zero report, which really helped kick off the Gas Goes Green programme and set out the stages of decarbonising the gas grid. This vision piece, in some senses, will effectively update that, but recognising that quite a lot has moved on and we know a lot more since when we first put that out. We know more about where the earliest production sites are likely to be. We know about where the hydrogen villages will be and potentially hydrogen towns as a first step towards a wider rollout. So what this vision is trying to do is bring all that together and really lay out not a rollout plan, but a plausible vision for a future in how hydrogen could be used in the grid. And this is recognising that there are still uncertainties in the policy space. So it's a plausible vision rather than an actual sort of estimation of what the future will be like. But what it's intended to do is provide a sort of one-stop shop, really showing a united gas network vision for how this could all work. So we're working hard on that now, and we'll continue to do so in the early part of 2023 and hope to be able to launch that relatively soon in the new year. And my second point here, I mean, James has already talked about blending at length, but just to reiterate, 2023 will be a really significant year for hydrogen blending, with government due to make their decision next year, subject to HSC approving the changes to the GSMR regs in order to go up to 20% blend. So as James has articulated, we've got work going on and specific projects around policy and supporting BEIS with the value for money case. The safety evidence will continue coming out of HyDeploy and Future Grid as well. And then we're also, through Gas Goes Green, looking at several projects to do with practical implementation. So the capacity allocation for blending, which James mentioned, license and regulatory changes needed for blending, and also that blending timeline that James mentioned as well. So given what I said at the start about pivoting the programme a bit more towards the actual evidence that's needed around key decisions, it's fair to say that 2023 will be a big year for blending on the programme. And then, of course, looking slightly further ahead, but still not that far ahead, really, we've got a decision on the use of hydrogen for heating in 2026. And there's a huge amount of work that's going on at the moment through the Gas Goes Green programme and with the wider gas networks to support government, HSE and others with putting together the evidence needed to make an informed decision on hydrogen for heat. So we'll be continuing to work very closely with government to feed in the evidence that they need, working on the villages, working on the towns in the longer term as well to help with that evidence. There is a keen focus on hydrogen in what we're doing on the programme, but our biomethane work will continue as well. Our entry customer forum, is still supporting producers to maximise biomethane injection into the gas grid. We've touched upon that a little bit already in one of the questions we had. We're likely to and hopeful that we'll see a bit of an uptick of activity on that side. The new green or new-ish green gas support scheme that came in roughly a year ago and open to applications will likely drive a real investor interest in this sector and an uptick in biomethane activity. So that's really a key part of our programme. Also, just to follow up on a point that was made in one of the questions about the role of biomethane versus blending, we'll also be looking to take this question really seriously on the programme, looking to evaluate the role that biomethane has in the short, medium and longer term in delivering the zero carbon gas grid and how it can work alongside hydrogen in the longer term. And then lastly here, but very importantly as well, we will be looking at the zero carbon gas grid of Gas Goes Green as part of our wider whole systems work that we do as ENA, and really looking cross-vector across electricity and gas to assess optimal decarbonisation solutions and really work out what is the role for hydrogen and biomethane as well in that whole energy system of the future, and how can it support the build out of low carbon electricity generation and actually come to a view on a whole energy system which is most efficient for the future. So this is work that's at a much earlier stage and is being progressed somewhat outside of Gas Goes Green, but related to Gas Goes Green through our whole systems strategy board, but is a really huge important part of the puzzle here. So that's it from me, a fairly quick overview of what we're up to, but a lot going on. I hope that was useful. I'll hand back now for any questions.
Thank you, James. And to all participants, please continue to ask any questions to James in Slido. We have one at this moment, so that's an easy choice. Can you say more, James, on the hydrogen vision, please?
Yes, that's a fairly open-ended question, but happy to say a few more things on that. As I said, really, the driver for this is recognising that there's a huge amount of work going on in the hydrogen space amongst the different networks. There's different projects that the GDNs, each of the GDNs are doing. There's projects that National Grid are doing. But what would be really helpful for us and for the wider industry and sector as well is really to pull that all together into one united vision. And that's what we're doing at the moment. And I would want to stress in this that this is not us coming together and saying this is what's going to happen. This is us coming together and saying, well, how do all these different parts of the puzzle fit together, and how could this plausibly roll out subject to policy decisions that we've got around hydrogen blending, but particularly on hydrogen for heat. So I think, as I said in my overview, that's something we're working on at the moment, bringing together the different projects, drawing up sort of maps based on data that we've got around how that rollout could work. And then we would hope to launch that in the early part of next year.
Thank you, James. Please all continue to feel free to add questions to James in the Slido. I do see that questions continue to come in on blending, and we still have a couple of blending questions that we didn't answer. So, James W., I think more questions for you. Let's take the one on the screen first. As far as I can see, any blending at the downstream nodes limits blending upstream. The blending must occur at the highest point upstream. And I think there was a related question earlier. Let me see what I can find that.
So I just pick. I mean, I could pick this one.
Yeah. Okay.
One up, and then if you find the other one, then that's fine. But so, I mean, if you were to design the perfect system, no doubt you would put the hydrogen in at the highest point of the network, as it were, because then you've got the blend, I suppose, everywhere downstream from that. However, there's more at play, I suppose, than just that. You've got actually geographical locations of where production is likely to be, which obviously influences where hydrogen can be injected. But then also bringing back to the point that blending is what we call a transitionary step to 100% hydrogen or other green alternatives. So in some ways we don't need to design the perfect system, as it were. We just need to design a system that works, that boosts hydrogen production, enables that to grow. And then these particular connections, if there's 100% hydrogen network of the future, could continue to be reutilized, to inject hydrogen into the network wherever they are. So yeah, it's a good question, and it links back to the first one around the upstream and downstream of blending. However, it's I suppose there's a lot at play in that particular area, and that's back to that piece of work that we're going to work through next year.
Okay. Thanks. Next question, I think, is for James Earl. Will you look to work with other associations, institutions, alliances who are pulling in the same direction?
Can I cover that one and the one above it at the same time? Or actually, yes, still the one above it at the same time. They're moving all over the place on my screen. Coordination across networks, producers, off-takers, and other bodies for planning and environmental permits is key. What role do networks have in that? So I think networks, by their very nature, at the very center of this. So we have a key role, and I see us as the trade association representing the networks having a really key role at the center of that. However, we can't do everything, and it's right that we shouldn't do everything. So actually, the best way that we can coordinate is by working with others who represent other parts of that value chain. And so that draws me on nicely to the other point, which is, will you look to work with others who are pulling in the same direction? To say that the clear answer to that is absolutely yes. We're open for business, so to speak. We work a lot with other trade associations and institutions. For example, we published actually yesterday, I believe, our response to the recent government consultation on business models for hydrogen transportation and storage. You can see that on our website, and that also includes a joint response that we put in with Hydrogen UK, REA, and CCSA as well. So there are a lot of different institutions and associations pulling in a very similar direction here. There are, of course, always going to be slight nuances in approaches and positions, but we want to work with as many people as we can to move this forward.
Thank you. I'm going to try to select those questions that got most votes earlier on. So that brings us to a question to James W. Could hydrogen gas purchase agreements like biomethane linking consumers with producers with some guarantee of origin, could these be possible using blending?
I think in short, yes. In theory, I don't see why not. But I suppose this is again for BEIS to consider in terms of what they foresee of the actual the rollout of hydrogen blending to be, and what that market framework looks like. So it's a work in progress, I suppose, from government. But I can't see why you couldn't do that. But whether they decide to go down that path, that would be a question for them.
Okay, thank you. Next one, how much hydrogen is needed to have a 20% blended network, and how much of the proposed 10 gigawatt of capacity will take this up?
So back to my previous slides, the 20% blended network across all of the network equals around 60 terawatt hours of hydrogen, and that's across NTS and distribution network. What we're saying there is that's the blending opportunity. So that's how much hydrogen production blending could support. What we're not saying is we need to do we don't need to do all of that. The premise of blending is to support production, and that's the prize that can go at. How much of the proposed 10 gigawatt capacity will take this up? I mean, production's planned at the potential production plans at the moment. Until there's an actual decision on blending, we'll see how much of that, I suppose, is likely to be blended into the grid. But yeah, it's I think I suppose the headline story is there's lots of opportunity for blending, and it can support it can support the 10 gigawatt target.
Thanks. Next question also for you. Is there consideration of phasing and sectoring of blending introduction around sensitive industrial processes, please?
So we're looking at what are conceived to be sensitive industrial processes within our high deploy program to understand, are there any sensitivities there, and if there are, what are they? Are they safety issues? Are they operational issues? Or can they be managed? So far to date, high deploy's found no showstoppers. With the caveat that work is still ongoing and set to conclude early next year, but we don't foresee there being any sort of showstoppers for blending. There will likely be a phasing of blending anyway, due to just due to the nature of hydrogen being produced, the amounts of hydrogen there are, maintaining compliance with billing frameworks, etc. So that will naturally happen anyway, I believe, which would I suppose smooth anything out. But ultimately, high deploy hasn't found any potential issues yet, and if it does, we'll look at what those potential solutions would likely be.
Thanks. Then let's go to the next one on the screen already. One of the non-tangible benefits of blending is the fact that it starts conversations with consumers about greening the gas they use. I guess the underlying question is, do you agree with that? And any further exploitation of that mechanism that you are pursuing?
Yeah. So yes, agree with that. I mean, there was lots more benefits actually than was presented on the screen. The screen was just sort of the big headline sort of economic drivers, as it were. But yeah, so I mean, the social benefits associated with blending sort of brings customers on board to move into a greener technology and using hydrogen actually as well. So some of the research we did under high deploy looked at consumers' perceptions of hydrogen before the trials effectively and after the trials. Some of the concerns people had before engaging in the trial were around, security of supply or, safety or whatever. There's a number of different concerns, but then at the end of the trial, we reassessed those consumers and they were really on board with the trial. We also asked them about have the trials altered your perceptions of 100% hydrogen, and the fact is that more of the consumers were likely to be on board with 100% hydrogen than they would have done it before the trial, which just shows that actually doing stuff just demonstrates that that things can be done, and we can manage it, and it's safe, etc. So no, very good point. But yeah, I mean, there's other benefits as well to do with blending. It can boost supply chains, etc. There's different things to do, benefits to do with safety and carbon monoxide reductions as well. So there's lots of benefits that weren't on that list that are also quite prominent.
Thanks. We have plenty more for you. But meanwhile, to all participants, continue indeed, as Lennart put in the chat, continue to ask any question to James O as well. James W, depending on what happens to demand, does 20% blend require 20% less natural gas to flow? And if so, how does that business case stack up without costing more?
So that's quite a good question. So it actually isn't a direct swap, 20% for 20%. So the energy content of hydrogen is different to natural gas. So it's effectively a third of what natural gas is. So a 20% hydrogen blend doesn't mean you use straight away 20% less natural gas. What it means is that you use some less natural gas, but not it's not the full 20%. But the carbon emissions that I referenced earlier take all of that into account. So yeah, I think in terms of does it stack up and without costing more, we're then back into what's the cost of hydrogen blending effectively. Now, the work we did on the infrastructure project is the costs are fairly minimal to actually blend hydrogen into the grid. We don't need to change primary or or billing regulations and new systems, etc., to get this happening. So in terms of costs to enable blending, there's not a great deal of cost there. What there is a cost of, obviously, is cost of hydrogen and cost of natural gas. So natural gas is obviously being driven by a lot of external factors at the moment, but the cost of hydrogen is something that BEIS are working with industry on at the moment to understand what that cost would be. And if blending becomes a thing, there'll be whatever subsidies or incentives will be in place to enable that to happen, which should also play through to try and keep the cost as low as possible for consumer. But it shouldn't really be any different from the price of natural gas that's being paid today, because it will need to be fair across the board. So whether you're receiving a hydrogen blend or you're receiving natural gas at another part of the network, I imagine Ofgem and BEIS would want that to be fair.
Okay. And the next question: can networks buy hydrogen as shrinkage gas, like they are looking at doing in Australia?
So that's one of the things that I mentioned earlier when asked the question who could buy the gas. So the networks already buy, natural gas to cover their shrinkage. So there's no real reason why we couldn't buy hydrogen, and that's another way that the market can be stimulated, and a fairly significant steady demand for producers as well. So, but yeah, good question. And it shows if they're doing it, they're looking to do it in Australia, they're on the same sort of lines of us.
Okay, how about the reuse of hydrogen at distribution? Are you looking at use of heat recovery from industrial hydrogen combustion for heat networks for domestic and commercial heating in clusters?
Sorry, could you repeat that one?
Yes, so regarding the use of hydrogen at distribution points, are you looking at the use of heat recovery from industrial hydrogen combustion for heat networks for domestic or commercial heating in clusters?
I don't believe that's something we've directly, I've not directly been involved in looking at. I don't know if anybody from the ENA is aware of any projects. Yeah. But,
I'm not aware of any specific projects, but ultimately this falls under the piece of work I mentioned earlier about our whole energy systems work. And primarily whole energy systems for ENA means electricity and gas, but it means other energy vectors as well as heat. So I'm not aware of a particular piece of work on it, but it's definitely part of the mix of our thinking.
Okay. Then let's do as a last question to James W, the one on the screen already. Iron mains replacement was highlighted in earlier slides associated with preparation. Do you have figures of what percentage of replacement has been completed to date?
I put up my hand because I think that's probably more for me than it is James W. But I'll kick us off, and if James wants to finish off, then fine. So for any that don't know, the iron mains replacement program is a program mandated by the HSE to replace old iron mains pipes with newer polyethylene PE piping. That's primarily for sort of safety reasons, but it has the nice convenient side effect that it also helps to ready the network to transport hydrogen as well. The way that program is being rolled out is on a tiered basis, and tier 1 is the area of focus at the moment, and that's those iron mains that are 8 inches or less in diameter and within 30 meters of a property. I don't have the exact figures to hand on the rollout for that, but it's somewhere in the region of about 3/4 of those has been replaced to date. And then according to the program, they must be replaced by 2032.
Thank you. And then James, maybe I can invite you to close it off, also asking you to combine that with asking the question on the screen, to what extent your hydrogen vision will include locationally specific visions, but not after thanking all the participants from the side of Lennart and myself for their active contribution and participation. With that, the last words are yours, James.
Okay, thank you very much. So yes, I'll just answer that one quickly to say it depends what we mean by locationally specific. It will certainly be regionally specific. We're building it bottom up in the sense that we're looking at hydrogen network infrastructure on a regional basis. that is based on data and analysis that we've done as a collective amongst the networks previously. So it would be built up as a national vision, but built up from a local or regional level. So it will certainly include that in there. So I think that's everything. So thank you everyone for your participation today. Thank you to our facilitators. Thank you also to the other speakers who spoke with me today. Hope this has been useful for everyone, and look forward to seeing you at the next one of these next year. Thank you very much.